Thanks everyone for coming out today. Thanks to NVScene for having me. Yeah, I feel really honored to be here. I've followed computer graphics all my life, and yeah, you guys are badasses, so it's pretty humbling to be up here in front of you talking about what I do. So today I'm talking about creating interactive visuals for large audiences. This is what I do for a living. It's what I've been doing for about 10 years now, more or less. And what this means is creating computer graphics, but in the context of creating it for a large number of people in a public space. And not really like a theater or anything like that, but a place where people just happen to wander through and have the chance to interact with the thing that you've built. So I'm going to walk through a bunch of projects that I've worked on, and I'm going to sort of talk about the tools that I've used, and also what worked and what didn't. So some of the lessons that came out of this experience. But first, a little about myself. I started probably the way a lot of you guys did. My parents gave me a Nintendo Entertainment System when I was, I think, 8 years old. And this changed my life entirely. Like, at this point, I knew what I wanted to do for a living. I wanted to create computer games and video games. And I didn't really leave the house a whole lot after this. But what I didn't realize was this is actually kind of bribery of a sort, because my parents were about to sell their house and buy a boat and go sailing for 5 years. And they actually did this. Like, this is what my years from 9 to 14 were. We sailed from Seattle to Turkey. This is me in the middle of the Atlantic Ocean. I think we're 15 days in the middle of a 30-day crossing. Yeah, and I'm supposed to be on watch, but me and my cat are passed out. But during this time, they managed to airdrop somehow Nintendo powers to all sorts of places in remote islands, remote countries. And this was just torture, because I didn't have like the latest hardware or anything like that, or the latest Nintendo system or Sega Genesis. But somehow I had this huge stack of glossy magazines of everything that I was missing out. The other thing that happened during this time is that Sierra Adventure games came out. So I started playing these like crazy. And I think Leisure Suit Larry, sadly, was the first computer game I ever played. My parents said if I could get past the adult check, then I could play it, and that took about 20 minutes. But there was something about these games. It was, I think, the open-ended interaction. Like, they were very different than a console game. You just kind of wandered into a room, and you saw a bunch of things in this room, and you had the chance to interact with them however you thought possible. So in this case, this person's about to sit on a geyser, which seems pretty ill-advised. But yeah, you could just do anything in the room, and there was very little context to these games. I mean, you knew that you were in a fantasy setting. You knew that you were in space or a police officer or trying to pick up women in sleazy bars. But there wasn't a whole lot of context as far as up meant jump or A meant fire gun or anything like that. And there was something really interesting about that. So yeah, I came back from the cruise, and I went to high school, and I went to college. And then I proceeded to work in the game industry for about a decade. I worked for all these companies you see up here, and shipped a bunch of games. And that was kind of where I learned to actually do graphics programming. And at CMU, I spent a week writing a ray tracer to draw one triangle on the screen. But this was working with tons of artists and tons of designers and building huge games and learning how to use OpenGL and DirectX. And it was really a valuable experience. But I knew it ultimately wasn't what I wanted to do. And so at the end of that time at Loose Cannon, I don't know if you remember this, but the Microsoft Surface came out. And this thing came out in 2008, so it's about the same time as the iPhone 1. And it cost $10,000 and weighed about 200 pounds. And for that, you got a 1024 by 768 screen. And the thing was essentially a coffee table, but it had some interesting things about it. Inside of it, there was a projector, 4 cameras, an IR light. The whole thing was very fragile. If you moved it, you'd end up having to typically recalibrate it. But there wasn't really a conception of how people were supposed to interact with this device. You put it in the middle of a room, people would wander up and put their hands on it. At this point, people didn't really know what a touchscreen was for either. At least the public didn't. And so Microsoft approached our studio, Loose Cannon, and I was in charge of making a couple demos for this. So this is one of the first games that I essentially shipped for the Surface, which was just kind of a tile-based game. And I did a bunch of graphics demos for it as well. But it was very interesting to work on, because there wasn't this conception of how you're supposed to interact with it. And you really could kind of write your own rules. People weren't expecting a first-person shooter, that's for sure. So this led me to the company where I currently work, which is called Stimulant. And Stimulant, around that time, was also working with the Surface, and they were writing more sort of application projects for it, like information kiosks and stuff like that. And what Stimulant does now is very different than what it did back then. What we do now is we build smart spaces, and we build experiences that fit in those spaces. And we typically work with architects and fabricators, and we design software and build software, ultimately, that fits in those spaces and changes how people perceive those spaces. And sometimes it's informational, sometimes it's experiential, sometimes we're just trying to impress people, sometimes we have a very specific thing that we need to do. It varies from project to project. And what I'm going to essentially show is a couple projects that I've worked on at Stimulant. I've worked on, I think, probably dozens of projects at Stimulant. So this is just kind of a random cross-section of different types of projects that we work on. And our projects are pretty short, typically like 3 months, sometimes longer, sometimes shorter. And they're very small compared to the 60-person development teams I was working on in the game industry. This is usually just one software developer, one designer, a project manager, and then a system architect that is in charge of kind of wrapping everything up and making sure that we have the hardware that we need and we can actually install this in the place that it needs to go. And a QA engineer, too, which you should never forget because they save your ass. So one of the first projects that I worked on at Stimulant was for Intel. We ended up doing a project for CES, the Consumer Electronics Show. And they wanted to build something that lived on this kind of crazy non-uniform rear projection surface. So they had this thing already in mind. And it was one of the weirdest things I've ever seen to project on. It was completely non-uniform, non-symmetrical. It made the projection mapping people's lives totally miserable. But they didn't really know the content that they wanted. They just wanted something to impress their audience and to demonstrate their brand. And they were willing for it to be really abstract and out there, which is the funnest projects to work on, really. There's definitely some challenges, though. This is at CES, so it's in front of a ton of people. And those people are constantly distracted. And it's very hard to get their attention. And also, it's incredibly public. So this thing really can't go down. It's the first time I'd heard about 5 nines reliability, which is the concept that it needs to be up 99.999% of the time, which essentially is just all the time. You should just say it has to be up all the time. But building something like that, particularly coming from the game industry, was a little terrifying, particularly knowing that it was going to be in front of so many people's eyes. So this is what we ended up building. If there's audio, probably for the best that there isn't. So that's the structure up there. It's, I don't even remember how many feet it is. I think it's like 180 feet wide, and it's 24 projectors, all projecting on the back of that surface. And the way that people interact with it is there's 6 different input stations stationed around CES, which is a mob with people all the time. And the idea is that you reach into one of these input stations, and it takes the silhouette of your hand, and then it procedurally generates a creature out of that. So we had all these jellyfish and stingrays and all sorts of things that could get created. But the creature was unique to them. Essentially, they could create a creature and then come back later and see it swimming around, and it would interact with other creatures in this environment as well. So it was kind of like a giant aquarium where you could actually build your own fish. Yeah, and during the course of CES, I think 30,000 creatures got created. It was in use pretty much all the time, and it was pretty hard to avoid, too. This thing was one of the biggest screens at CES that year, and definitely the most unusual. So I'm going to talk a little bit about what that entails from a technical standpoint. So quite a bit, actually. It's pretty hard to find a graphics card that has 12 outputs and can drive that many pixels. So we ended up going with something where we had a ton of client machines. I think it was 12 client machines, each outputting to 24, each to 2 projectors, so 24 projectors. And then this shows 4 input stations, but really we had 6 input stations, all feeding into a centralized server that would manage the sort of entire state of that ecosystem. And so how did we build that? Well, the framework that we went with, which I'd never used before this, is called VVVV. I would say V4 because it's really hard to say. But it's a framework that a bunch of Germans made that is pretty interesting. It's a node-based programming language, which if you're familiar with Touch Designer or Max MSP, it's very similar. The idea is that you connect a bunch of nodes together, and the output of one node feeds into another, and then that does some operation on it and sends it on to a bunch of other nodes. And it's all in real time, so you can hook anything up however you want. You can pipe stuff into shaders, pipe that back out. It's great for doing GPU particle systems, because you can program the entire thing in real time. The other really nice thing about it that was great for us is that it's got this concept of boy grouping, which is a terrible name, but I keep coming back to it. And they say boy grouping because it keeps everything in sync, which it just makes it that much worse. But yeah, the idea is that you don't end up writing networking code, really. Essentially, you make one patch, and then you define the nodes that are going to run as the server state, and then you define the nodes that are going to get sent off to the clients. And that all happens underneath the scene. So implicitly, all this stuff, your server state gets pushed down to the clients, and just the state that you want does. And then the clients are responsible for things like offsetting their viewport to the correct portion, or calling out creatures that don't really belong in that space. Because it's a node-based programming language, you can really make a mess of it, though. People always say spaghetti code, but spaghetti graph code is something else entirely. It's literally spaghetti. This is an early version of our program, which fortunately got cleaned up at some point. But yeah, it's just horrible all the way down. Like if you open up any of these boxes, it's more of the same, and you can just keep driving down and down and down further into it. So it's not the most maintainable thing, I would say. Like we had comments all over the place, but if someone gets hit by a bus, it's going to take a little while to figure out what the hell's going on here. But yeah, the boy grouping is pretty amazing. Here's one of our early tests with boy grouping in action. So this is a bunch of particles just kind of flying across the screens. These are multiple computers driving this. And this is really one patch. Like we're not writing networking code at this point. We're not writing server code. We just wrote one cool patch that shows particles flowing across the screen, and then start up V4 on a bunch of other clients and hit run, and this is what you get. So it's for scaffolding things like this, it's super valuable. And then we went back to rendering, like how do we make this thing look the way we want? So this is an earlier rendering test. And you've got some caustics here, some specular highlights, probably way too much bloom. There's God rays coming out when creatures get born, and a shockwave, and we just piled on the effects. So yeah, at this point we're feeling like we've got the colors locked, we've got a good look, we're representing the brand well. And then kind of just combine those two. So here's the first idea of having an actual ecosystem up and running on multiple computers. So we create a little creature, let him loose. He can swim around until he gets eaten by another creature. At this point, we're feeling pretty good that, like, oh, okay, this thing looks cool. We can create creatures. We can set them loose. We can do it across a ton of displays. We're not really like limited by that at all. But you still have the question, how do we make this interactive? I mean, people need to connect with it at CES. And that question remains of like, we want ultimately this not just to be a pretty picture up on the wall. We want people to feel connected with it. And so technically how we did that is OpenCV, which you guys are probably familiar with. It's very appropriate that we use this. It was developed by the Intel Russian Research Center in 1999. And it's essentially a grab bag of computer vision algorithms. So you can kind of take what you want and leave what you want. And much like before, you take an input like video or a static image, and then you feed that into one of these operations and take the result of that and feed it into another operation, and so on. I believe it's now totally GPU accelerated. Maybe not totally, but heavily GPU accelerated. So also a lot of this stuff now runs in real time. And will run on your GPU, which is fantastic. And here's an early version of our input station. So this is my desk lamp, a webcam, a sheet of paper, and my hand sticking up there. And we do this a lot. We just kind of build it out of whatever pieces we have. And this is kind of what that thing would see. So we're running through the OpenCV operations here. We're doing the camera, and then we get the background, and then we create the grayscale image of that. And then we do a background subtraction. So we take that background that we have already, we subtract it out, so we get just a really clean image. And then we don't care about grayscale, so we turn that into binary. We clean that up. And finally, we run a contours algorithm on it. And that gives us the silhouette that we want. And so at this point, we can start moving on from using Adobe Illustrator paths and starting to create these creatures out of actual things that we put, that people could bring with them, or their hands, or any other body part, really. Yeah, and some of the coolest creatures were just created by sticking random tiny stuff in there. Glass of water was pretty fun, but like a paper clip or a cell phone or anything. And it was fun to see because once these creatures were up there, you could actually see like, oh, that someone created that out of their cell phone or their wallet or their keys or whatever. But there's a lot more to this than that. We needed it to run rock solid for 7 days. And more importantly, we needed it to not do something terrible if the worst happened. And so this is a lot of what we work on. It's not the funnest thing, and it has nothing to do with computer graphics or GPUs, really. But we wrote like a heartbeat monitor to check up on all these systems that we had, since we had 20-odd computers running concurrently. And you know, this application would essentially ping all those computers and say, are you doing OK? I want a response from you. Tell me what your FPS is, or how much memory you have, what state you're in. So we do a lot of this. And this thing lets you glance at it at a site or in a second and tell, is something wrong, or is everything running OK? And that's really important when you're biting your nails for 7 days, just to have this sort of admin console. So this is the other thing we do is we stage things a lot. This is what it looks like in our office. You know, we build everything out as many times as possible, and we build it with the real hardware if we can. And you've got our janky input stations and all these computers running. And yeah, there's pretty heavy GPUs in these things. So our office, I think, went up like 5 or 10 degrees during this time. So we didn't have we paid for heating in a different way, I guess. And then this is kind of what it looked like when we were on site. So this is behind the scenes, just running all these computers and giving us a glance of what people are seeing. And this was not the most fun part of the project, but essentially spent 7 days just behind there looking at these monitors, waiting for something bad to happen and respond. And nothing did, thank God. But it's part of all the projects we do, is particularly ones that are very outward-facing. And for conferences, is that you really spend some time just being totally racked by nerves, waiting for the worst to happen, and then it never does. Knock on wood. So that's one type of project that we do. Another type of project is we started doing observation towers a while back. And once we did one observation tower, we seemed to do a lot of them. We ended up doing one with a fantastic architecture firm called Gensler in Dallas. They were redesigning a tower that's in the center of Dallas, and they were essentially doing all the architecture for it and coming up with the aesthetic and building all that. And then we were working on doing the digital portion of it. And this is a very different type of project, because this project ultimately has to stay operational for years. I mean, this thing is still in Dallas, and you can go up to the tower and play around with all of it. So it needs to be rock solid in a very different way. It needs to have a lifespan. So here's the project that we ended up building. That's Reunion Tower right there. It's covered with all these little LEDs. And they can actually program to do crazy different light shows. And we did part of it that incorporated that as well. And yeah, you can see the overall aesthetic here is lots and lots of triangles, which, coming from a graphic standpoint, makes me happy because I know how to draw triangles. The other thing we were dealing with here is we were dealing with like a 3D world. So we wanted to model the city of Dallas and let people move around the city of Dallas and explore it as if there was kind of a virtual Dallas in front of them. There's also all these computers are hooked up to a centralized system, and so the whole ribbon of computers is one contiguous wave. And if you do something on one, you'll see it sort of reflect across all of them. I think that more and more is an important part of everything we do is we want it to feel whole. We don't want it to feel like you're staring at a single screen. We also hooked up motion sensors, so as you wander around the place, you'll see waves of light sort of follow you across all these screens. So there's tons of motion sensors in the place, and it reacts to you even if you're not actually interfacing with one of these displays. And there's a bunch of informational stuff in here too, so you can find out like where the closest Applebee's is, and all of it's kind of situated based upon where you are in the tower. So this was a very different type of project, and ultimately we used pretty different software on it. We ended up going with a framework called Cinder, which you guys have probably heard of as well. It's Andrew Bell will probably kill me for saying this, but it's a wrapper around OpenGL and GLSL, and it provides a lot more functionality than that. But it's made by Andrew Bell, Steve Scheibel, Robert Hodgin, and a bunch of other guys who are total badasses. And this framework is just, it's kind of my dream come true of a framework to use. It's really stable, it's rock solid, it's really well designed. They put a lot of thought and effort into it. It's totally free and open source. Yeah, it's just really fun to use. There's a little bit of a learning curve. It doesn't quite hide a lot of the things from you that processing and open frameworks do. But what you can do with it is pretty amazing. I think Andrew says it makes easy things easy and hard things possible. And that's really what we need. Also using C++, we know we can incorporate different types of hardware into it. If it has a C++ library, we can get it to work with Cinder. And that's really valuable. We don't have to wait for someone necessarily to write a library for us or a framework that connects. We can immediately take that hardware and start using it in our projects. So that was the client side of things. On the server side, we ended up going with Node.js, which I'm sure you guys have also heard of. And it's a web server and many other things built on top of I believe the Chrome V8 JavaScript engine. So it's surprisingly fast, gives you tons of support for every type of networking you'd want to do. We use a lot for OSC, but we also use it for admin consoles, web consoles, TCP, UDP, just about everything. Yeah, it's great. You can get something up and running in like 2 seconds with it. Disadvantages, in my mind, I know people will disagree with me, but it's JavaScript. And I'd left JavaScript like 10 years ago, and I was not ready to come back. And so, yeah, JavaScript has lost a lot of its warts, but it's still not my favorite language. And the other thing is that it's all asynchronous. So everything you do has to be asynchronous, which means you write a lot of callbacks. And you get into this thing called callback hell, where you're waiting for one callback so you can send another callback, and then another callback. And you look at this code, and you just, I don't know, it's very hard to understand. It's not my intuitive way of coding. But it worked great on this project, and we've used it a bunch since then, so I will not talk any more crap about it. So here's us actually mocking up what we're going to build. We do this a lot. This is us mocking it up at scale. So this is what it would look like if those two displays were actually made out of paper and were sitting on a piano stand. But there's a ton of value in this. It really teaches you a lot about what you're building and whether it's going to work, and whether the scale is right, whether things are the right size as far as the text, as far as the placement of things, so that you can reach out and touch whatever you want. And there's a ton of things that just fall out of this design that are super invaluable. And then this is us trying to do boy grouping in Cinder. And I went on too much. Yeah, Cinder and Node.js. So this is very primitive, but it's just a bunch of crap moving across the screens and telling us that we can actually pull this off with however many number of displays we want, and it's not going to be hell. And then there's the challenge of actually getting it to render, which, oh my God. Keynote, what have you done? Yeah, so we'll give it another sec. Oh, there we go. So yeah, this is, for some reason it's playing back chunky even too. This is just an early test of drawing lots of triangles, moving across the screen, getting some cube maps working, lots of procedural geometry of just like generating a ton of triangles, putting them on the GPU, moving them around, and trying different sort of like Perlin noise and sinusoidal movement to try to get to be the effect that we want. And then more mock-ups. I mean, we built so much stuff out of paper on this project. This is, since we're dealing with the world of Dallas, this is a prototype of what Dallas is going to be like. And you might laugh, but this is a great way to figure out the camera moves that you want and the perspectives you want and how you sort of want to look down upon this world and plan out all these different moves through a 3D world. Yeah, and then we also worked with a lot of 3D modelers to actually build the city of Dallas and do camera fly-throughs. And this is a very early model with terrible lighting. But you get the idea of like, we have the city of Dallas now, and now we can start working with it and incorporating it as part of the interface design. Yeah, and then this is the light show again. So we had a whole thing where you could play around, design your own light shows. This is an early version of what the tower would look like with all these lights lined up. And we actually had to figure out where the lights perfectly matched onto the tower were. And they pretty much had no documentation of where the lights were, or how many there were. They didn't even know how many lights there were, really. So we kind of had to reverse engineer this strange structure, which took a little bit of effort. But the project worked out really well. This is the final product. You can go up to the top of this tower in Dallas and play around with all this stuff. And it's rock solid, and it really just runs day after day. And it's very different than that previous project. I mean, this is stuff that is going to live in the wild for a long time. And you have to have backup computers. You have to have redundancy. You have to train a staff that knows how to do all this stuff. And you also have to respond to sort of changes in how people use it. I mean, it might turn out after this thing living in the wild for a year or two that people aren't finding some module or something like that. And so you have to go back and sort of rethink some of the experiential things in certain cases. Yeah, and then the final project I'm going to talk about is different than even those two. This was kind of just a fun project that we ended up doing. Our Seattle office has been big fans of the Decibel Festival, which is a techno festival that happens up in Seattle. We have a lot of ex-ravers in our office. And we worked with them a couple times doing small projects, but we wanted to do something bigger this last year. And Microsoft also approached us and said that they had a new piece of hardware that they wanted us to work with. And it was kind of a crazy piece of hardware. It was an installation piece that has, well, it's called the Microsoft Cube, and essentially it's a 4 by 4 by 4 foot cube sitting on top of a 2-foot stand. And each side has a rear projection surface on it, and then also has a Kinect facing outwards. And so you can wander around this thing, interact with any side of it. And it's got a ton of computers in it. And the idea is it's just kind of supposed to be a Kinect cube, so you can, from any side, approach it and have an experience playing around with this gigantic cube. Excuse me. So here is what we finally built. This actually lived in one of the main venues at Decibel. Very loud, noisy environment. Yeah, and that's the cube itself. And the idea is that you can, well, actually, here's us first building the cube, so some assembly required. Yeah, and there's all these projectors in it. Anytime you're dealing with projectors and you move anything, you pretty much have to plan on spending about an hour recalibrating everything. And there's the Kinect 2s all situated in the bottom of it, and then this gigantic top that's a rear projection screen. I think that's it up and running our software for the first time. And the idea behind what we built is that you're reflected by an avatar on the side of the cube that you're on, and We affectionately called him Cube Man, but essentially it's a guy made up of a ton of cubes that track to your body's movements and also have some physics to them. And you can kind of dance with Cube Man, but you also see people across the cube, so you can see through the cube kind of, and you can actually see people on the other side, and you're connected with them by ribbons. And so the idea was, in this kind of dance space, you'd come up to it, you'd see people on the other side, you'd have your own dance experience, but you'd also see other people dancing, and you could connect with them through this sort of virtual avatar system. So yeah, that's the cube. But once again, how do we build it? Well, the time frame on this was very short. So we ended up going back to Cinder, which was great because we knew how to build stuff in Cinder. And we ended up going back with Node.js. And we were also dealing with a lot of connects. This is the Connect 2, which I am guessing everyone's familiar with. This thing had, I think, 4 Connect 2s. And the Connect 2 is really the best sensor that $150 can buy. It's a wide-angle time-of-flight camera. So you get a pretty nice depth image that's about twice as good in resolution as the original Connect, and a whole lot less noisy. Additionally, it can track up to 6 skeletons, and it does a pretty good job of that. You get like 25 joints, I think, and fingers, and it can detect your heart rate. It can detect facial expressions. It's a little creepy, actually. But you also get HD video. You get audio, including orientation or position of that audio. You get a really nice IR image. So if you want to track fiduciary markers or IR reflective tape or anything like that, this thing's fantastic because it's both an IR emitter as well as an IR camera. Yeah, it's just a great device. I mean, I can't put into words what a deal you're getting for $150. So yeah, here's me trying to hook things up for the first time. My picture's actually not that interesting. And then here's me playing around with sort of the volume for the first time. So we had this idea that like the view that you have is the view of you sort of virtually looking into this volumetric space. And you wouldn't actually see the other side. We didn't want to like show the image of this dark club on the other side. But we wanted it to feel like, oh, I see someone actually approaching this thing from the other side, and I'm approaching from this side, and there's a sense of 3D space between it, and we can actually connect through that space. We also did something where we tracked your head, and we actually changed your perspective based upon where your head was. But experientially, that just didn't work because there's going to be 6 people on this side, at least on one side, and so we couldn't have the viewpoint popping around like crazy. And here's an early version of Cube Man. So he's made up of a lot of cubes. And we got the ribbons going. And then we added some sort of turbulence flow to it, because we didn't want the particles to just disappear as soon as you walked off. We wanted them to have a little bit of lifespan. And so if you wandered back in, they would kind of get sucked back into you. But otherwise, we wanted it to feel like this thing was filled with sort of viscous fluid, and these cubes were floating around. And then as you approached, they would become part of who you were. And when you left, they would still exist in the system. So yeah, here's one of the first times we got everything working, I think, with all 4 sides and lots of cubes everywhere. And then we also made it audio reactive. So I don't know if you can actually, yeah, you probably can't hear the audio. But the idea was, since this is going to live in a music venue, we piped in the audio from the mixer on stage, and we did an FFT on it, and then use that sent that to the server, and then use that to modulate things like lighting in the room and the size of the cubes and the width of the ribbons. And a lot of this code, actually, we ended up turning into an SDK that's a public SDK. And I'll link to that later if you guys want to take a look at it. But I think a lot of the Node.js code and the Cinder code is now public and completely open source to play around with. So that was just a really fun project that we got to work on for a couple months. And I think it was close to our hearts because we really like electronic music, and we worked with Decibel a bunch. And it was just fun to work on a project where you get to kind of go outlandish and be creative and think of, what would I want to build and what would I actually want to interact with without necessarily having a client driving those decisions. So yeah, I'm going to talk a little bit about some of the lessons that we learned, mostly the hard way in building all this stuff. It's definitely very different trying to build stuff for clients, and it's very different trying to build stuff that interacts with the public. There's a lot of challenges, and yeah, it was very much a learning process. The first lesson is design and build to scale and for your medium. You probably saw a lot of mock-ups in this, and all of us trying to actually figure out what it's going to be like for this thing to actually exist in the wild. And every sort of medium that you're using is totally different. Projection, touchscreens, physical displays, all of them present their own challenges. And one of the worst things is ambient lighting is just awful. I mean, the sun is really your enemy, particularly with projection. It's just having something that is in a dark room is totally different than having something that is projected in a space like CES with tons of ambient lighting and tons of noise and tons of distractions. And it washes out surfaces, but it also sort of washes out the experience. If you're not careful, it's really hard to stand out from all that noise. And this goes along with it. Plan to change everything on site. We move everything into config files. We have tons of sliders on screen. For that first project, we actually built a huge touch OSC controller that we could change the color of everything. We could change the speed at which creatures moved. We could change just about everything in the system remotely. And that allowed us to really kind of dial in what we wanted it to look like and respond to things like the projectors not looking as bright as we wanted them to be, or things moving too fast across a giant distance, or people getting disoriented. So, I mean, really, those small tweaks at the end of the day make a huge difference. I think once you actually finally see it on site, like, those tiny adjustments really can make like a 25 or even 50% difference in how things are actually perceived. Getting someone to engage is at least half the battle. I mean, it's really hard in the public space to get someone to come up and interact with what you've built. It takes a lot of faith on their part. They need to feel safe in order to approach your project and take the chance of interacting with it. It's dancing in front of a cube is not something that comes naturally to people. And I think that, you know, in a dance club, it's a lot easier. But if you're trying to get those interactions out of people who are just in a random public space, there's a lot of thought into trying to get them to feel safe and feel comfortable actually coming up and just approaching your project to start out with. And this goes along with it. Really, all interaction should result in something beautiful and meaningful. You don't really want to have a failure state, typically. I mean, this isn't Counter-Strike. You don't want someone to come up and interact with your thing and then feel like they got headshot. Like, you want them to be able to come up and even if they have a very shallow experience, you want them to feel like what they did was worthwhile and they got something out of it. And that will actually draw them in further, too. I mean, if you can give the shallow experience some sort of reward and feedback, they'll be more likely to actually come and interact with it deeper, and they'll also be more likely to show it to other people in a public space. Yeah, keep it alive. Failure is often not an option. It's fun to do tiny little projects, but a lot of the stuff that we do from a technical standpoint is not fun computer graphics programming. It's building heartbeat monitoring. It's putting in automated restarts so things restart every night. It's putting in lots of logging so we know what went wrong when something does go wrong. It's racking up backup computers so down the line if something crashes we can swap things in minutes rather than hours. Building failover systems so there's not a blue screen of death up if something happens. We put a ton of effort and energy into this, and it's not the funnest thing in the world, but it makes a huge difference. And this one's kind of the closest thing to my heart, is that I really feel like real-time coding frees your mind up to be more creative. I really do believe that all coding is creative, that what we all do and the decisions we make all are very creative decisions. But I also feel like the compilation step really kills a lot of it. Waiting for something to compile for 5 minutes takes you out of that creative zone. And I think that the more you can use things like GLSL shader compiling, it takes a fraction of a second to recompile a GLSL shader. Lua scripting, VVVV, all these things let you work more immediately with your medium, and they really let you connect with it. And they also let you work with creative people much closer. I mean, if they want you to adjust the particle system, they don't want to wait 5 minutes to see it. They want it to see it immediately, and then they want to make adjustments. And having that feedback loop with creative people is incredibly valuable. So finally, I'm just going to, I think I'm running out of time, so I'm just going to mention some additional tools that I've used and found useful. The first one is, this is up on, I think, my Cinder account, yep. And this is just an embarrassingly small amount of code that shows you how to hot reload a GLSL shader. So if you don't know how to do this already, this is useful. But it totally changed my life of just being able to write and save GLSL fragment and vertex shaders and immediately see the results of it. So I use this on a daily basis. It's super, super useful. And there's a bunch of different ways of doing this, but there's one example up on here that's pretty useful. And also, if you don't get these, I'll post these to my Twitter account later, so they'll also be up there if you need them. So this is actually another thing that I wish I had time to show, but I don't really. One cool thing you can do is you can recompile just about any C++ language, Cinder included, as a Quartz Composer plugin. And what that means is if you're trying to do visuals for a live audience and you want to respond to music, OSC, MIDI, you want to go out in the audience with a touch OSC controller and let people play around with it. One great way you can do this with leveraging Quartz Composer is just make it a Quartz Composer plugin. And then your module, which you built in Quartz Composer, you can drop into any VJ software. You can drop into VDMX, you can drop into Koji, you can drop into Resolume. So if you want to play around with that, there's an example up on my GitHub account of a very simple version of doing that. I think it's Memo Atkins Simple Harmonic Motion, written as a Quartz Composer plugin. So for almost all the visuals that I've done, this is kind of how I do it, is I just write it as a Quartz Composer plugin, and then I just drop it in anywhere that I need it. And then the other thing is that Cinder doesn't really have a UI framework, and unfortunately, well, not unfortunately, we end up doing a lot of UI as well. So I wrote my own UI framework that's pretty extensive, or we wrote a UI framework, and it's called Cinder XUI, and it's an XML markup language for doing UI in Cinder. In addition, it's got Lua scripting, and you can load GLSL shaders. And if anyone wants me to show an example of that at some point, I can do that. But all the source code for that is up on the Cinder XUI repository. So that's been super, super useful, and I definitely recommend checking it out. And then we also wrote a SDK for the Microsoft Cube, so feel free to check that out. There's a bunch of different pieces to it. It's got some Node.js, it's got a bunch of Cinder, a bunch of Unity, a bunch of processing. Whatever language you want to use, I think most languages, we wrote some source code to get you started. It's also got this handy app called Connect Transport. So if you want to consume Connect 2 data in a platform that does not support the SDK, essentially you can get this Connect Transport protocol and some source code to send it across to JavaScript or Unity or just about anything. So it's pretty handy if you need to consume Connect 2 data. You can even send Connect 2 data to an OS X application or an iPhone. So you could foreseeably write an iPhone app that was consuming Connect 2 data with this thing. So it's pretty useful. Yeah, and that's about it. Thank you guys all so much for coming and for sitting through this.